Welcome back for the third example. This time, we're a telecom industry company and we would like to find groups of our clients that use our services in similar ways. This is essentially an example of customer segmentation. Let's set our working directory, clean up the memory of our current R session, and load our dataset. As we've done so far, let's explore our dataset with the str function and check some simple statistics with the summary function. The output of the str function tells us that we have 1000 observations and 5 variables. Our variables are the following. First, the calls variable, which is numeric and which represents the average number of hours of calling per month for each individual in the data set. Then we have the intern variable, which is numeric and which represents the average number of hours spent by the user in international phone calls. Then we have the text variable, which is numeric and which represents the average number of text messages sent by the user per month. Then the data variable, which is numeric and represents the average data usage per month in gigabytes. The last variable is the age variable, which is an integer variable and which represents the age of the user of the line in years. Let's check out some summary statistics. Here you can see that the mean of the text variable is around 225.02 and the mean of the data variable is about 1.97. These are clearly on very different scales, and as we've done before, we are going to make our variables comparable by normalizing our dataset. So we create a copy of our dataset called taste data, and then we scale our variable with the scale function. We now compute the distances as we've done before with the dist function and perform hierarchical clustering with the hclust function. Now let's decide, like you did in class, to have 8 clusters. So we create the groups variable that we add to our original data set called data and use the qtree function to assign our points to our 8 clusters. Then in order to get a nice output table, we compute the mean values for each variable and for each group by using the aggregate function that we've used before with the fun argument. Like we've done in the HR example, we compute proportions by using the calls variable here and the length function, and add the proportion by computing the ratio between the number of observations in each group and the total number of observations. To better organize our output table, we order the groups from the one with the largest number of observations to the one with the smallest number. You can then save your output table by using the write.csv function that we discovered in the HR example. From a telecom company point of view, 8 segments might be more than what they actually want. Let's try again with 5 segments and see if some of our segments can be treated similarly. So back to our code, we change the groups variable to qtree hc word as a first argument and k equal 5 for 5 segments this time. Let's run it. Let's check out our output table by typing data. Now you can save this output with the write.csv function, or if you have some issue with the separator, you can use the read.csv2 function. So far in this tutorial, we have not used R a lot to create our visualization. So let's see how you can use R to create a radar chart to better visualize the output of our clustering. This code will allow you to replicate the charts shown by Professor Gladdy during the lectures. First, let's select the colors that we want to use with the palette function, to which we pass the rainbow function. Then, in order to create the radar chart, we use the stars function. Feel free to explore all the arguments of the stars function by typing $stars in the command line. In the right bottom corner of my screen, you can now see the output, which is the same radar chart that you obtained in class with Professor Gladdy. This wraps up our recital for this module. I hope you learned a lot and will play around with R in order to solve your own problems and explore your own datasets. See you next module.